Inverse of the functions below. So we have g of x equals 3x plus 4. And we have f of x equals x minus 1 quantity squared minus 7. So those are the two functions. Last class we went through how to find inverse functions with our 4 steps. So we're going to use those same 4 steps for each of these problems today. Francesca, you can pick which one to start with.
I have not finished yet.
Oh, that's okay. I'll give you a minute to finish up. And let me see if, nope, Erin's still not back. Oh, look, maybe she is. Yay. Okay, so Francesca, pick one that you are finished with and we'll just go ahead and do it. And it's okay if you're not like totally done, we can still talk through it together.
The first one.
Okay, so it's the very first. Francesca, are you there?
Yeah, I didn't hear what you said. It kind of cut.
Oh, I'm sorry. What's the very first step?
Oh, okay. Rewrite the equation so replace the x.
The g of x, right? That whole thing.
Replace the g of x
with y. Yeah, and then go ahead and do the second step for me. What do we do in step 2?
You swap it, so instead of y equals x is x equals y.
3y plus 4. Okay. And then let me see. Francesca's gone. Tanaya, can you do step 3 for me?
Can you say it again?
Yeah, what for step 3?
Then you subtract 4.
Yeah. And now what?
And then you divide by 3.
Okay. We were solving for y. So we get y equals x minus 4 over 3. And then Brandy, what's the very last step that we did?
Then we don't you?
You have to. Oh.
Go ahead, Brandy.
You have to write in f inverse of x.
Yes, exactly. But because this is labeled as g, we're going to do g inverse of x equals x minus 4 over 3. And then you're done. Good job, guys. Erin, can you start me off with the next one?
I can try.
Yeah, go for it.
Hold on. I really don't know. I really don't.
So what happened in the first step in this problem? How do we get from this line to that line?
You changed it to y.
Yeah, so what should I write here?
Y equals x minus 1 to the second power minus 7.
Perfect. And then in step 2, what changed from here to there?
The x and the y.
Yeah. So what do I write?
X equals y minus 1 to the second power minus 7.
Perfect. Good job. And then let me put all these back. Francesca, can you help me out with step 3? How do I solve for y here?
Plus 7?
What did you say was something?
Plus 7?
Yeah, perfect. So I get x plus 7 equals y minus 1 quantity squared. And how do I get rid of this square?
Square root, right?
Square root.
Yeah. Okay, and don't forget that you can have plus or minus the square root. So I'm going to have that plus or minus the square root of x plus 7 is equal to y minus 1. And what's the last step that I need to do? How do I get y all by itself?
Divide.
Well, what operation is going on between y and 1?
Don't you add?
Oh. Subtract.
Yeah, well, we're going to, yeah, subtraction is going on, so we do the opposite of that, which is adding. So then my final product should be y equals 1 plus or minus the square root of x plus 7. Okay, and I'm just going to tell you guys for step 4, we're replacing y with f inverse of x equals the same thing we just got. Okay, what questions do you guys have about that whole process?
So, parentheses?
Tanaya, were you asking something?
Yes, I was about to ask something.
Okay, you go ahead and then Aaron.
With the parentheses, we don't distribute the squared? We just square root it?
That's a really good question. Yeah, so distributing the square requires you to FOIL this whole thing. Okay, because y minus 1 squared, I'm going to do it up here. Y minus 1 squared is the same thing as saying y minus 1 times y minus 1. And so then you'd have to distribute all this stuff and you end up getting y squared minus 2y plus 1. That's a lot more difficult to try to isolate y with.
Okay.
Okay, so that's why we take everything away that's outside of the square and then we square root it to get rid of the square.
Okay, so once you square root it, then that's when the parentheses just drop?
Yeah, exactly. The parentheses drop when we square root it because it's not squared anymore. It's just y minus 1 by itself.
Okay.
That's an excellent question. Thank you. Aaron, what's your question?
I know y'all probably took notes on this last class, but I couldn't find the recording, so I don't know what to do.
Oh, okay. So let me show you where the recording is first. And where I have it is where it always will be, so you'll be able to go back and access any of them. Let me make sure, yeah. Okay, so this is our class. Go to modules, wherever that is. Okay, and then we'll scroll down to last class. So last class was on the 14th. And click on it. And you go to the Microsoft Teams meeting activity. So like for today, it'll be on this like Microsoft Teams meeting. If this ever loads, oh my goodness. Okay, there we go. And then if you just like this is what you would normally see, but if you keep scrolling, so first I put the solutions here so you can go back and look at the notes all filled in, and then you can follow along with the class in these videos.
Okay.
Okay. So that should hopefully help you out. Make sense?
Yeah.
Okay, so today's class, Erin, is like it's related, but you don't need last class to know it. So you should be able to jump in today and it'll be fine.
Okay.
Okay. And let me know if you need an extension on any of the stuff from last class. Okay.
Yeah, the homework. I didn't get to do the homework.
Okay, I'll go back in and I'll make sure I extend it for you. Remind me at the end of class today.
Okay.
Okay, perfect. Great. So for today, we are talking about domain and range. So I'm going to pull up my document camera again. All right, and we're going to go through two different sheets. Both of these sheets and the solutions. I have to sneeze. Hold on. Excuse me. Both of these sheets and the solutions are already online. Let me double check and make sure I'm recording this meeting. Because I don't want to not have it. Forgot to record one of my meetings 2 days ago, and it's terrible. Okay, so we are going to first talk about different notations. We're talking about domain and range today. So first we're going to talk about different ways to write domain and range, okay? And we're going to do it by looking at number lines and writing like what this is in mathematical notation, because on a graph, our domain is the interval that our function is on the x-axis. So we're looking basically as the x-axis would be a number line. And then we're looking at the y-axis itself for the range. And so we're considering the y-axis as a number line, essentially. So some little tips that may be helpful. This open circle means it does not include the value. And that's going to correspond to round parentheses or a less than or greater than sign. Okay. And this should be review. The closed circle means it does include. And this would be square brackets or less than or equal to or greater than or equal to. Okay, so we're talking about two different ways to notate this. We can do interval notation or set notation. You're probably a little bit more familiar with interval notation, so we'll start there. So let's see. Tanaya, can you tell me what the lowest value on this number line is that we're going to include?
Is it zero? No, is it? Isn't? I think it's 0, but
Yeah. And is it included in the number line?
it looks open.
Yeah, it is open. Good. So we're going to use a round bracket because it was not included, and we use the round bracket when it's open. And then the upper one, what's the upper number going to be for this graph, Brandy?
7.
Yeah, and this is also open. So I meant to ask you, I'm sorry, but you're going to use round bracket. Okay, so questions on that interval notation for that particular number line? Okay, now set notation is a little bit different. With set notation, you're always going to have these curly braces on the ends. The curly braces represent a set in mathematics. So basically a group of things together.